Hey, Allissa again. I hope this is going to be the last video letter to you guys. Um, and it's a doozy. It has a lot of information in it. So, whew, let's get going. Um, we've talked all about the eyes. We've talked about the touch sensors. And we got really into the nitty gritty with cell conformation um, and shape change. Maybe I'll go down another route, but I have a tendency to get online and yeah, there's my bug bites again. I know they look nasty, but they don't itch as much. Yeah, I go down these rabbit holes and I can sit at the computer for hours and not even know that hours have gone by. But I did some research that I'm not going to share with you because that just brings me into another tangent, but it's about some new medicines that Scripps research is developing for people with anxiety disorders. And this was just a mind boggling idea. And I'm hoping it comes to fruition. But there was great information about cell surface receptors. Now, granted, we've been talking about PSO, we've been talking about mechanoreceptors, but these cell surface receptors, there's three different types. It's the transmembrane of the cell that's sensing. And we talked earlier about evolution and how evolution, when she finds a way that works, she keeps it. And it's evolution is a she because Mother Nature, Mother Nature. And as we saw from the hand with all the little bugs on it, if we can start thinking of these mechanosensors, these sonic pressure sensors, these cell surface receptors, these piezo channels, ion channels. Um, if we can start thinking those of an ecosystem, and quite honestly, any ecosystem, when you go out in nature and there's silence, there's no wind, there's no bugs chirping, there's no birds, it's quite eerie because there should be quite a few little critters in the forest and out in nature, and there should be wind. So it's not a good feeling when you're out by yourself and it's dead silent. Dead silent. Yeah. So these self surface receptors are also listening and they're the sensing switches of the cell, it says. There's three types of these transmembrane receptors. My writing's very small. One is an ion channel receptor, PZO1, PZO2, for we'll get into a little bit later with Ardem Hataputian's information. And it says here when ligand binding creates shape change of a receptor, when ligands bind, that creates shape change of a receptor. And when shape changes of these ion channels, then more ions are allowed to pass. So that's sodium and magnesium and calcium, um, hydrogen, uh, and calcium. Well, if we have more calcium and sodium potassium pump, we've heard of that. So the muscles are going to be better. And calcium is really good for our bones and for our muscles and the electricity. So if we're going to go really down to the small scale and then the microscopic scale of our body, we also do that in nature when we study the smallest little critters in the ocean because all those plankton and everything that we have and the bacteria that's made our oxygen are super important to our health. So if we go into our own bodies and we look at these ion channel receptors or GPCRs, G protein coupling receptors. Is that right? Oh, yeah. G protein coupled receptors. They're an opioid receptor, and there's a massive family of them. So it was Hugh Rosen at Scripps in March of 2024, March 21st, 2024, that gave that lecture about anxiety disorder. And these G protein coupled receptors, they're opioid receptors. And I can't tell you the details, but I will say that my mom, when she was moved from one unit to another unit, and they said this is hospice and it'll be better for her. Boy, they put her on some opioid receptors, opioid medication. And from September to November, I went from a mom that was telling me that she was married and she had a job and a husband that came home every night to somebody that didn't say a thing, didn't talk, didn't even forgot how to swallow. So these opioid receptors, they do a lot. Okay, so three types of transmembrane receptors: ion channels, GPCRs, G protein coupled receptors, and then the third one is enzyme linked. So when they function, when they open and there's a shape change or ligands bind to that cell receptor, ligands binding on the transmembrane causes enzymes to be activated. So phosphorylation, enzymatic activity of a receptor, epidermal growth factor, platelet-derived growth factor, all of those things are done. And what I find interesting about the PCOs is because Ardem Pataputian has talked about this in numerous lectures online, that the activation is critical for bone health. Bones change. White blood cell, red blood cell, those change when there's a PCO ion channel opening. Skin is responsive to these channels. And let's go back to the bone because we talked about scoliosis and having two alleles from both mom and dad is more likely that the PCO2s that are causing scoliosis are wonky. Anyway, blood changes, lymph vessels change, and mechanosensitive tissues also are very sensitive to PCO ion channels. So when there's more rigidity, we can add more magnesium. And when more ions can pass through because the channel opens, that's a higher electrical signal. And that's like winning. That's like winning the lottery. And then changes in mechanosensors, sensing that changes fat tissue, because as Ardem Pataputian talked about in his China Beijing lecture, I should find out for you. I should. When fat tissue is when mechanoreceptors are sensing fat tissue, another thing is activated, and this can also they can activate DRG neurons. And those DRG neurons robustly innervate fat. Cool, isn't it? So that helps to put the brake on the sympathetic nervous system. It helps to regulate adipose tissue and function. And then if we as a hands-on body worker are coming in to help deactivate the sympathetic nervous system, that's creating a whole new system of channels that are opening. And I think I'm getting over my head, aren't I? And then changes to hormone secretion, communication with the brain, sympathetic tone changes. Hey, let me show you what I was talking about with Ardem at the Beijing conference. And then talk about a couple of things. Yay, I found it. Let's see if I can share this because that's really cool. So this is kind of in the background of my, yeah. So I got a whole folder on Mr. Pataputian on the Chinese, the Beijing thing. So caption, why sensors are sensing fat. Yeah, look at that. No, maybe you can't see it. Ah, I gotta stop this. Stop share. Because I don't think you can see that. So we have a book here titled A Sound Mind, and Nina Kraus is a neuroscientist, and she has done path-breaking research on sound and hearing for more than 30 years. And A Sound Mind, how our brain constructs a meaningful sonic world. So there's the term sonic. Sonic. You know, the last time we discussed, the last video, we discussed the ecosystem. So if we think about hearing, basically it's an ecosystem. There's a tympanic membrane, and there's bones, and there's fluid, and there's outer hair cells and inner hair cells, and outer hair cells around 90,000 and inner hair cells around 30,000. I mean, this is an outstanding number. And all of these little species that are in there, they live in this environment, and they want to have it clean, really. I think what I'm going to do is going to write in the show notes about the hearing, because that will be easier. Hey, I'm gonna come back and do this another day, because I I've worked today, and my head just isn't working the way that I want to, because yeah, I'm tired. So um maybe I'll send this, maybe I won't. It's got some information, but for the most part, maybe it's more 9B than anything. What I will leave you with, if I do share this, is let's see. No, let's not do that. Let's do this. Yep. This is what we're going to end with, because we did the ecosystem, the little critters on the hand. So I did a lecture and a class about how to do your own treatment. And one of the slides that I had, really loved, but it's about how a wet inner ecosystem is good for us. And here's my little critters on the hand. And the body, just like nature, is like nature, and it adapts all on its own. I mean, when we talked about, I don't have the book handy, but What is Health? Peter Sterling. Maybe Peter Sterling is an osteopath. I don't remember, but he just has such a vision, very similar to Andrew Taylor Still. And this wet inner ecosystem is so important, because as we can see from this water, it's creeping along, and it goes in all different directions. And we give so much credit to the blood. Yeah, our circulation system is very good, but our lymphatic, where does the lymph come from? And it's all these fluid filled spaces. And that is something from Neil's paper, and others, about the pancreas, that maybe that's where I'll end. But when when we think about the body being exactly like nature, because evolution, she has done a great job, so she's keeping the same thing. All of this thrives when it's it's reacting to itself well, and it's adapting all on its own. No one told fish what to do and how to swim. They just they do it instinctively, but also um, maybe they have some sort of blueprint. But all of these little critters rely on each other, on their home being healthy. And the same is true for when we have nerve conduction from the vagus nerve all the way up. So here's a great picture of the vagus nerve and how it innervates the digestive system, and it goes up to the ear and behind the ear and then into the face. And obviously, with Stephen Porges, you're going to talk about that so much more. This is something that I actually didn't use, but we want to stay mobile. We want to stay adaptable, and we want to stay stable. And here we see the rugby player, the handball player from Denmark. And this was in a Swedish newspaper from 2021. And I do have a better picture of it, but you can see the ball and it just hits her face. And yes, she had tears in her eyes because it hurt, but also it stung. And she sat on the bench for a while and she said, "Hey, coach, I can go back in." And so she finished, and it's a great story. But you can see that ball actually deform her whole face, and it absorbed the shock, and she was able to play again. Whereas this guy in 1973, Amar decided to raise his hand up, right arm, for his God. And there's a lot of suffering in there, but that was part of his plight. And so, unfortunately, this became so stiff. So this is nice in 50. This is nice and wet, and this is very dry. So we want to keep things moist, 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 moist. Yeah, and that's the other thing. Let's leave with Dr. Neil Feast. So this is an excerpt from his. I say his, but it's quite a few people. You can see on there, there's quite a few people. So July 2025, human pathology and fluid-filled spaces. There is sound that has to be going through this. It has to be a sonic pressure. Um, you know, a fluid-filled space, if you think about what it is to have glaucoma, you have high pressure glaucoma, you have low pressure glaucoma. One is very treatable, the other one not so much. And I can't say which is which. But the IS, when they talk about it in their paper, the IS is a fluid-filled space. And it says, although contents of the large fluid-filled spaces in particularly have not been fully studied, all the IS, the interstitial fluid-filled spaces, contain hyaluronan and collagen. And most also, they appear to contain elastin, proteoglycans, a variety of glycosamine glycans. Recent studies have used hyaluronan binding protein to map hyaluronan fluid networks within formalin-fixed paraffin embedded human tissue. Given that hyaluronan is highly hygroscopic and would support fluid flow, albeit slow flow, these studies supported the concept of a body-wide network, showing that all interstitial fluid-filled spaces are continuous within organs such as the skin, colon, liver, and between adjacent tissues such as skin, and its underlying subcutaneous fascia, as well as colon and its sub-adjacent mesentery. Moreover, adventitious sheaths and perineurium contain interstitial fluid-filled spaces that are also in continuity with the tissues through which they pass, and thereby provide body-wide continuity along the entire cardiovascular and nervous system. That is so very cool, isn't it? I mean, it is. It's the coolest. If we go back to this one, then you see that this inner ecosystem is very moist, and these nerves have to conduct. And everybody, and even not a scientist, knows that you don't stand in a puddle of water if there's a live wire around, because that live wire is going to go all throughout the water. And if you're standing in it, especially barefoot, not a good idea. All right, I think I'm done. Yeah. Oh, yeah. So I have this on my website because I made it possible for the people that were in the learn your own treatment. Is it's based on science and research, and so the force is with you from Ardem, and then this is an awesome one. It's the announcement of.
Ladies and gentlemen, good morning and very much welcome to Nobel's.
It's the announcement of the Nobel Prize for Ardem's research and David Julius, and it's a. I can't describe to you how well done it is, but this particular man, right there, he gives a whole lecture about what it is for the somatosensory system. Pat Enforce. Oh, Patrick Enforce. I think that he is part of the Nobel Prize committee that helped select it. So awesome. All right, I'm done. Yes, I'm very much done. I'm gonna go hang out at home, and I wish you a good night's sleep, so what? And maybe I'll be back tomorrow with the last one, the installment. So hopefully that wasn't too much. Okay. All right. Bye.